All right, so like I said, a lot of times in calculus, we come across problems that we don't have rules for on how to take the derivative. Well, if you look at your green sheet, you can see down here number 15. This is one that we have not used yet. It's a differentiation formula that we have not gotten to yet. And to take the derivative of natural log of u, it's always going to be 1 over u times the derivative of u. So u could be anything. If u is just x, that's great, because then our answer is just 1 over x, because the derivative of x is 1. But if our u value is, say, x squared, then it would be 1 over x squared, and then what's the derivative of x squared? 2x, so it would be times 2x. So this is the new one that we're going to be using. So looking at some examples here, we're given these formulas here at the top, and of course it says that if we're taking the derivative of ln of x, that's just 1 over x, which we just talked about. But if we're taking the derivative of natural log of u, we have to do 1 over u times du dx. And that just means the derivative of u with respect to x. We're using the chain rule. Another shortcut way to do it is it's u prime over u. You're welcome to use that if that makes sense to you. I always show it with the chain rule just to go a little bit slower with it. So right here on this problem, I would identify my u. Right there it is. So to find the derivative, I have to do 1 over that. So it's 1 over 3x times the derivative of the u. So what's the derivative of 3x? 3. So it's times 3. So 3 over 3x would just be 1 over x. That's our derivative right there. For example 2, here's our u. So to find that derivative, the first thing I have to do is it's going to be 1. Let's put y prime equals. So y prime equals 1 over this u, and then times, and what's the derivative of the u? 2x, so times 2x. So we're just going to have 2x over x squared plus 1. Nothing else that we can do with that. All right, so the first two have been pretty straightforward. This one's just a little bit more difficult. The reason why is because we have an x times ln of x. So that means we're going to have to use the product rule. Sometimes people, they say, well, why can't I, if this is a coefficient, why can't I make it an exponent? That rule only holds true if this is a constant. So like if this is a 2, 3, 4, then we could do that. But the way it is, we're forced to use the product rule. It's a product of variables. So this is going to be f, this is going to be g. You may remember the product rule? It's been a while since we've used it. Very good. That's our product rule. So here's my f is x. So f prime is just 1. G is just natural log of x. Plus f is x. G prime, what's the derivative of ln of x? We just learned it. Derivative of ln of x, guys? 1 over x. So times 1 over x. So now we have natural log of x plus x over x is just going to give us 1. Why aren't I putting plus c at the end of these? You may know I'm not putting plus c. When do we put plus c? With not derivatives, but integrals. So there's no plus c necessary. All right, this one is even a little bit more challenging. Sometimes people say, okay, with this 3, can't we just pull it out in front? No, you can't. If the problem had been ln of x cubed, where the x is just getting cubed, I could rewrite that as 3 natural log of x. But this is the whole quantity getting cubed. So I have to start by thinking of this as u to the 3rd, and I'm going to have to use the chain rule on it. So the derivative of u cubed is 3 u squared times the derivative of the u. So what is the derivative of ln of x? Come on, guys, we just learned it. What is it? 1 over x. So our final answer then is going to be 3 natural log of x squared over x. We had to use the chain rule. Just going through this one again quickly, it was u cubed. That derivative is 3u squared. The derivative of the u is 1 over x. And then we simplified. All right, for something like this, if I just start this from the way it is, I'm going to have to do 1 over the square root of x squared minus 1. Then I would have to do the derivative of the square root of x squared minus 1. It's very difficult to do this problem unless I expand it first. So another way I could write this would be ln, natural log, of x squared minus 1 to the 1/2. What do we do with an exponent of 1/2? Where can it go? If it's just with this, where can it go? Out in the front. So here's what my problem is now. The reason why this is easier is because when I take this derivative, I just bring down the 1/2. The derivative of ln of something, ln of u, that derivative is 1 over u. I'm using this formula. Derivative of ln of u is 1 over u. But then I have to do times the derivative of the u. What's the derivative of this x squared minus 1? 2x. Well, I can go ahead and cancel these because I have 2 divided by 2. I might as well do that. So in the numerator, I'm left with x. In the denominator, x squared minus 1. That would be our final derivative. Questions? All right, and let's look at this last one. This one would be impossible to do without expanding it, because we'd have to use the product rule, the quotient rule, the chain rule. All of that would have to be done within the same problem. It's too much. So we're going to expand it to make it easier. So can somebody kind of tell me the first step in expanding it? It's going to be natural log of what? X plus, now what? Good. And then what? Minus what? Oh. All right. Very good. Okay, so once we have them written out like this, it's going to be a lot easier than trying to use the chain rule, the product rule, and the quotient rule on the same problem. So now I have terms. The derivative of ln of x. What is it, everyone? 1 over x. Plus, I come to the next one. I bring down the 2. Derivative of natural log of this is 1 over that. And then times, and what's the derivative of x squared plus 1? Times 2x, right? And then minus, I bring along the 1/2. And the derivative of natural log of this is going to be what? 1 over it. And then what's the derivative of that? 12x squared. I could just put that on top here. So now putting this all together, each term has to remain separate. So I've got 1 over x plus 4x over x squared plus 1 minus, I can go ahead and divide these because this is multiplication, so I can cancel those. And I have minus 6x squared over 4x cubed minus 1. And that would be our derivative. Anybody remember what derivatives find for us? Slope, the specific rate of change of 1 point. Okay, good job, guys. So you have that second assignment up there, page 322, 45 through 57 odd, and then number 71.